Right now, the petrol in your vehicle is not just fuel. It's a living story that is millions of years old. Imagine, once, it was microscopic organisms floating in the ocean. Then they got buried beneath the earth. And today, the same thing is giving speed to your bike. But how? Is there really a lake of petrol beneath the ground? Or is it all just a big illusion? And if petrol doesn't come out directly, then how is it actually made? The truth is far more dangerous and fascinating than you think. Thousands of meters beneath the earth lies a black, thick crude oil, which is not easy to extract. And turning it into petrol is even harder. In this video, you will see the mystery inside the earth, the real science of oil exploration, and the process that turns dirty crude oil into the power of your vehicle. So next time you fill petrol, don't just look at the price. Understand this. You are filling millions of years of history into your tank. First, let's go to the place where this story began. Not thousands, not lakhs, but millions of years ago. At that time, the Earth had vast oceans, lakes, and swampy regions. In these places, tiny marine organisms, algae plants, and organic matter existed in huge quantities. When they died, their remains began to settle under the water. Gradually, layers of soil, sand, and rocks kept piling over them. Time passed, layers became thicker, depth increased, and with depth, pressure and temperature also kept rising. And this is where nature begins its magic. Over millions of years, due to intense pressure and heat, these organic remains started breaking down into substances called hydrocarbons. These hydrocarbons eventually form crude oil and natural gas. In simple terms, the real origin of petrol and diesel lies in a natural, chemical process that took place deep inside the Earth over millions of years. But there's one very important thing to understand here. Petrol is not stored underground in ready-made bottles, nor is crude oil found in open underground lakes. Crude oil is trapped between special types of rocks beneath the earth. Some rocks are porous, meaning they have tiny spaces where oil and gas can accumulate. But if the upper layer is also porous, the oil would escape upward. That's why nature needs another element, a hard, non-porous layer that prevents the oil from moving upward. When oil is trapped below and sealed by a strong layer above, it stays there. This is what we call trapped oil. And to find this trapped oil, major oil companies around the world spend billions. Now the question is, how do humans even know that there is oil beneath the ground? Because digging randomly everywhere is not possible. That's where scientists come in. Geologists study the layers of the earth, the structure of rocks, and the geological history of a region. They try to identify areas where conditions might have been suitable for oil formation. After that, special surveys are conducted. Sound waves or vibrations are sent deep into the ground, and scientists observe how these waves return. Based on the returning waves, they estimate the structure of the layers below. In simple words, just like a doctor uses a scan to see inside the human body, scientists try to see inside the earth. If the structure looks promising, then exploratory drilling is done. That means first investigation, then estimation, and finally testing. Finding oil itself is a huge victory. When it is almost confirmed that oil exists beneath the ground, drilling begins. A massive machine is installed on the Earth's surface, called a drilling rig. If the oil is on land, the rig is set up on the ground. If the oil is beneath the ocean, then drilling is done by building platforms in the middle of the sea. Then, a very strong drill bit starts, cutting through the layers of the Earth and moves downward. This depth is not just a few hundred meters. Many times, it reaches thousands of meters. During drilling, it's not just about making a hole, but also about securing it. Steel pipes are inserted, and cementing is done to keep the well strong and to maintain control over the internal pressure. A special fluid is also used during drilling, called drilling mud. It keeps the drill cool, brings the cut rock fragments to the surface, and helps manage the pressure inside the well. This means the very beginning of oil extraction. Itself involves high-level engineering. Now, many people think that once drilling is done, oil just gushes out like a fountain. Sometimes that does happen, but not every time. In some oil wells, the natural pressure underground is so high that oil starts rising to the surface on its own. But in most cases, over time, the pressure decreases and pumps are needed. You might have seen in movies or documentaries a machine that moves up and down, almost like it's nodding its head. That is a pump jack, which pulls oil from beneath the ground. In some places, water, gas, or steam is also injected underground to push the remaining oil upward. In simple terms, finding oil is not the only challenge. Extracting every last drop is also an art. But wait, we still haven't got petrol yet. What comes out of the well is a black, thick, sticky crude oil filled with impurities. It doesn't just contain oil, it may also include gas, water, salt, mud, and other substances. So first, at the field level, separation is done. Natural gas is separated, water is removed, and then the crude oil is sent forward. This crude oil is transported to refineries through pipelines, rail tankers, large tanker trucks, or massive ships. And this is where the real magic begins, where this raw, dirty, and seemingly unusable oil is transformed into some of the most essential fuels in the world. Now, let's understand the refinery. A refinery is a place where science, chemistry, and engineering come together to convert crude oil into different useful products. But before that, there's one more important thing to understand. Crude oil is not a uniform substance. Crude from different locations is different. Some crude is light, some is heavy. Some contain less sulfur, some contain more. Some produce more petrol, while others yield more diesel or heavy oils. That's why every refinery must first understand what type of crude it has received and how to get the best possible output from it. In the refinery, the first step is cleaning the crude oil. The water, salt, and some impurities present in it are removed, because these can damage the machinery. After that, the crude oil is heated to a very high temperature. At around 350 to 400 degrees Celsius, different components of the crude begin to turn into vapor. This hot mixture is then sent into a very tall tower called a fractional distillation column. The name sounds complex, but the function is simple. This tower is hotter at the bottom and cooler at the top. The lighter substances rise to the top because they can separate at lower temperatures, while the heavier ones stay in the lower sections. In this way, a single crude oil is separated into different parts based on their boiling points. At the very top, gases are collected, which are used to make LPG and other gaseous products. Below that, a light fraction like naphtha is obtained. This naphtha later becomes a major base for making petrol. Further down, kerosene or jet fuel range substances are separated. Below that come diesel range hydrocarbons. Then heavy gas oil, furnace oil, lubricating oil base are obtained. And at the very bottom, the residue remains, which can be used to make bitumen, the black sticky material used in road construction. Just imagine, from a single crude oil, we get cooking gas, petrol, diesel, aircraft fuel, lubricants, and even road material. That's why crude oil is often called liquid gold. But even now, the petrol fraction obtained is not the final petrol that can be directly filled into your vehicle, because modern engines are very precise. They require a fuel that burns properly, produces less smoke, does not damage the engine, and delivers good performance. This is where advanced refinery processing begins. If the crude produces more heavy fractions, but the market demand is higher for petrol, the refinery breaks down heavy molecules into smaller ones. This process is called cracking. In simple terms, large hydrocarbon molecules are broken into smaller, more useful fuels. That's why a refinery doesn't just separate crude, it transforms it. After that comes a process called reforming, which is extremely important for improving petrol quality. For petrol, proper combustion is critical. If petrol burns incorrectly in the engine, it causes knocking, meaning vibrations, noise, and reduced performance. So, refineries modify the molecular structure of petrol to increase its octane number. In simple terms, the octane number tells how smoothly and in a controlled way petrol will burn inside the engine. The higher the octane, the better the combustion. Similarly, for diesel, cetane quality is important so that it ignites at the right time and performs effectively in compression ignition engines. Now comes one of the most important cleaning processes. Crude oil often contains sulfur and other impurities. If these are not removed, burning the fuel will create more pollution and can damage both the engine and the exhaust system. That's why modern refineries use processes like hydrotreating to significantly reduce sulfur content. This is also the reason why standards like BS6 are implemented today. Modern petrol and diesel are much cleaner, more refined, and more controlled according to environmental norms compared to the past. In other words, the real job of a refinery is not just to turn oil into fuel, but to make it suitable for the modern world. Now, let's understand the difference between petrol and diesel in a very simple way. Both start from the same crude oil, but they are different fractions and have different natures. Petrol is lighter, evaporates quickly, and is used in engines that burn fuel with a spark plug. That's why it is used in bikes, scooters, and petrol cars. Diesel is slightly heavier, has a higher energy density, and ignites on its own when compressed and heated. That's why diesel engines are considered better for heavy-duty work. Trucks, buses, tractors, generators, and many industrial machines use diesel because it provides both power and efficiency. In simple terms, they are like brothers but with different personalities. Even when petrol and diesel are almost ready, the story doesn't end. In refineries, additives are mixed into them. These additives make the fuel more stable, reduce deposits inside the engine, protect against corrosion, improve combustion, and sometimes even affect mileage and cleanliness. That's why you see a difference between normal fuel and premium fuel in the market. The base product is the same fuel, but its finishing and additive package make it slightly different. After that, the finished fuel is stored in large storage tanks. From there, it is transported to different depots through pipelines, rail wagons, road tankers, and ships. Then from the depots, the fuel reaches petrol pumps. And finally, that same petrol or diesel goes into your vehicle's tank. Now think about it. A liter of petrol that you fill in just 2 minutes has behind it millions of years of natural processes, scientific exploration, deep drilling, heavy machinery, refinery chemistry, and a massive transport network. Truly, what's in your tank is not just fuel, but the essence of time, science, and the depths of the earth. Now let's simplify the entire story in one straight flow. First, nature converts organic matter accumulated in oceans and swamps into crude oil over millions of years under pressure and temperature. Then scientists identify where this oil is trapped beneath the ground. Then drilling is done, wells are created, and crude oil is extracted. After that, gas, water, and impurities are separated. Then the crude oil goes to a refinery. There it is heated and separated into different fractions. Heavy molecules are broken down, fuel quality is improved, sulfur is removed. Additives are mixed, and only then final petrol and diesel are produced. So in one line, the answer is this: petrol does not come directly from the ground. What comes from the ground is crude oil, and petrol and diesel are made by humans through multiple scientific and chemical processes in refineries. But there's one more important thing to remember. Petrol and diesel are very valuable because they are non-renewable. They take millions of years to form. This means we are using them much faster than nature can recreate them. That's why the world is now moving towards electric vehicles, biofuels, hydrogen, and clean energy. Still, even today, a large part of transport, agriculture, industry, aviation, and daily life depends on petroleum products. So, the story of crude oil is not just the story of fuel, it is the story of modern civilization itself. So next time you stand at a petrol pump and watch the numbers rising on the screen, don't just think about the price, think about this. The fuel going into your vehicle is the final stage of a geological story that began millions of years ago. A journey that started with microscopic organisms floating in the ocean, went deep into the earth, was discovered by scientists, extracted by engineers, transformed in refineries, and today, it powers your bike, car, bus, and the machines of the world. That's why petrol and diesel may look ordinary, but their story is extraordinary. If someone now asks you how petrol and diesel come from the earth, you can confidently say, petrol does not come directly from the earth. What comes out is crude oil. And that crude oil is processed through multiple scientific and chemical processes in refineries to make petrol, diesel, and other fuels. And that is the real story of the fuel that powers today's world.